plus, what do we say? A half rotation would screw things up, right? What's a half rotation? Pi. That's 180 degrees. So if I add pi, that would be bad, wouldn't it? How many times could I do a half rotation, though? As many as I want, right? So you can either use a k here or an n is the standard notation. I'm going to put it down here. Where k is an element of z. Anybody know what z is? Everyone knows what script r is. That's the real numbers. But what's script z? Integer. So this is basically the set ... -3, -2, -1, 0, 1, 2, 3, ... forever. All integers. I'm going to go up to the board again because I think this is critical that you understand this. You first have to know, before you can do this, answer this question, you have to know where cosine is 0, right? Cosine is 0 here and here. That's where it's 0. Then you have to realize that, look, if I start here, pi over 2, and I add to it, let's try k is 0, okay? So if k is 0, what do I get? Pi over 2, right? Now let k be 1. Sorry, 1. What would I get? Pi over 2 plus a pi. Pi is a half rotation. So I would go there, wouldn't I? So I get that answer. Then start back here, pi over 2. Now let k be 2. So I'm adding 2 half rotations. 1, 2. Back up there, right? And then I could add 3, and that would have brought me back here. And I keep on getting all these infinite answers, right? Do y'all see this or not? Then what about negative? Pi over 2. Instead of rotating this way, I rotate the other way. And every single one of these answers is a different answer, isn't it? I mean, pi over 2 is pi over 2. Pi over 2 plus pi, what's pi over 2 plus pi? Well, pi is 2 pi over 2, isn't it? I did that to do what? Why did I do that? To get a common denominator? So I put them together and become what? 3 pi over 2? So by adding pi, it becomes 3 pi over 2, which is different than pi over 2. And if I add 2 pi, then I get common denominator again, and I get 5 pi over 2. So you get all these different answers. But this is the general solution. And we did not want our x to be that, right? We said don't let x be those numbers. So that's why I put it like not equals through there. Right? I put that not equal sign through there. No, you in this class you don't have to tell me k is an integer. It would be more proper to do so, but I understand that it would be understood that k is an integer. And like I said, some textbooks use an n there instead of a k. And it's the same thing. N is an integer. So use n or k. All right. That's... Oh, we still have a few more. Yeah, we can knock these out and we'll take our... I think we're going to be taking a break. Yep, we are. Just after this next example. All right. So anyone who just walked in, you need the notes or anything? Yes, one copy of the notes. How about syllabus? Yes. Syllabus, just you got everything? No, notes, yeah. All right. So I'm on 1.1.19. Determining a function. Express the area of a circle as a function of its diameter. Express the area of a circle as function of its diameter. What does that mean? Wrong class? Oh, man. Would have been fun. All right. What does this mean? Area as a function of its diameter. If I write down f of x, that means I have a function. This function is a function of which variable? X, right? I want, not f of x, I'm going to write it this way. I want a of what? A of d, and I can use capital D or lowercase d, but d is the diameter, right? That's what I want. I want a function that gives me the area of a circle if somebody gives me its diameter. That's what I want. So what is the area of a circle? You have to know that before you begin this problem. If I have a circle, and if I know its radius, area is what? This should be a common formula that you would know. Pi r squared, right? Isn't this equation giving you a relationship between the area and the radius? You give me the radius, I give you area. That's not what I want, though. I give you diameter, you give me area. So what could you do here to this formula to make it in terms of diameter instead of radius? Yeah, you need to know the relationship between the radius and diameter, right? So I'm going to put here, but your radius is always half the diameter, isn't it? Or if you want, the diameter divided by 2. Those mean the same thing, right? Half d is the same as d over 2. I would encourage you to get used to writing things more like the one I highlighted in yellow, as you'll see later on in this class. If you have a constant underneath a variable like this, just write it as a fraction out in front. So I know that the radius is half the diameter, so I can rewrite that equation up there. Area equals pi times the radius, but radius is half the diameter squared. So the area is pi times what? Square that. What do you get? 1/4 d squared. Remember, to square something in parentheses, you must square both factors, right? So you square the 1/2, right? 1/2 times 1/2 is 1/4. D squared is d squared. And so I would probably write something like this. Area as a function of diameter is equal to 1/4 pi d squared. The key to this problem and to the next ones is that you have two variables you're trying to connect, and you have to use your knowledge of geometry in order to connect them. The thing that we had to know here was, first of all, area of a circle is pi r squared. And the next thing we had to know is that the radius is always half the diameter. But let's look at the next example and see what it is we're going to have to know. Express the volume of a cube. Wait, volume of a cube? Volume of, oh wow. Volume of a cube as a function of its surface area? Okay. So what is a cube? Yeah, it's six-sided. It's like, you know, all equal sides. So like a die, right? A dice die, right? Isn't singular die? Okay. So I have a die. How do you draw a die? There's the front, goes back, comes down. Oops, I don't like that. Okay, so there's my cube. All the lengths of all sides are equal, right? So let's label some sides. I heard X. That sound okay with you? X, that means this is X, and that means this is X. And I know the volume of that is what? What's the volume of a cube? X times X times X, so X cubed. That I know. Now, do you know anything about the surface area? Okay, now I'm going to write A instead of, for surface area, I should do like SA or something. I'm just going to write A. Is everyone okay that that's going to mean the area, the surface area? The area is, okay, so tell me the area of just this front side right here. The area of that is x squared, isn't it? And how many sides are there? 6. So shouldn't the area be 6x squared? So what I need now is a final formula that gives me the volume as a function of what, though? Surface area. I need to somehow connect the volume and the surface area together. So how are you going to do that? Everyone understand the question, what we're trying to do? What do both the volume and the surface area formulas have in them? They both have an x, right? So why don't we try and solve the area formula for x? Take that answer and stick it right here for x. So I'm going to take this right here and solve it for x. How could I solve that for x? What would be the first thing you could do? Divide by 6. Now, I'm not going to divide. I mean, I'm going to divide, but I'm not going to write a over 6. I'm going to write 1/6 a equals x squared. Is that okay? Now what? Square root, right? And when you take the square root, what do you always have to do when you take the square root on both sides of an equation? You always have to do plus or minus, right? However, in this problem, do we need to look at negative? Why not? Because x can't be negative, right? X is the length of the side of a cube. So it's negative. I don't need to consider it. Y'all agree with that? Now, just for the sake of understanding radicals, do you agree with this? The square root is the same as raising something to the 1/2. Now, let me come back and I'll do it in red here below this. What did we say the volume was? It was x cubed. But now the volume is actually, what was x? It's 1/6 a to the 1/2. But then what are you going to do with that? Cube it, right? Y'all see what I did there? And what do you have when you have something to a power to another power? What do you do to these powers? You multiply them. So our volume is actually 1/6 a raised to the 3/2. And that is a pretty clean formula right there. If somebody gives me the area of a cube, I can take 1/6 of it, and I can raise it to the 3/2. What does it mean to raise something to the 3/2? You cube it, and then you take its square root. That's what that means. You can also do it the other way. You can take the square root first, then cube it. But I'd say that's a good formula, right? The only thing left to do would be maybe write V of A equals 1/6 a to the 3/2. That's just writing it as a function, okay? Like f of x, I'm writing it V of A. All right. Why don't you try the next one on your own? Or you can talk amongst each other in groups. And as soon as your table all comes to an agreement, you can take that first break.